Hello, thanks for tuning in to watch the fourth of our demonstration series for the Omniot Soft Hub platform. In this video, we'll again be extending the functionality of our original example, Example 1. We'll introduce flag and logging action objects, as well as illustrate how to manipulate input and output GPIO pins connected to external hardware. As with our previous videos, we'll follow up the configuration file creation with a brief live demonstration. In this example, we'll again connect to the same ANT and Bluetooth low energy sensors as before and forward any packets received to our remote AWS server. However, as you'll see in the live demonstration, we've connected button and LED hardware to two GPIO pins on the Soft Hub device. We've connected the button to an input pin and the LED to an output pin. When the user presses the button, it will toggle logging of the packet data to the Soft Hub's internal storage. Data will still be forwarded to the AWS server. It will just be additionally logged as well. Lastly, the LED will be illuminated anytime logging is active. So let's get started by opening the original Example 1 configuration file. As before, we'll keep all the original settings and objects from Example 1. First, we'll enable our input and output pins. Here we enable pin 17 as an output pin, and pin 6 as an input pin. For pin 6, we set a 20 millisecond debounce timer and also create an associated event object to be queued every time the button is released. Next, we'll create a flag action object to keep track of when we are actively logging. We'll initially set the flag to false. Now we create the logging action object for the ANT sensor and provide a log file name we want the object to write to. Similarly, we do the same thing for the Bluetooth low energy sensor. In this case, we're using the same file name, though we could just as easily choose to write the data to a separate file. We create a toggle GPIO pin object to toggle the voltage on our output pin connected to the LED. And also a toggle flag object to toggle the flag we created to keep track of when we're actively logging. And our final action object will turn the LED off by setting the pin's voltage to low. Now we create a state object to check the value of our logging flag. And with that, we're now ready to create our complete rule set. First, just for clarity, we'll rename our current event objects before we add in any new ones. With that done, we'll add an application starting event trigger for our initialization rule. In that rule, we're going to create and initialize our logging flag and also ensure that our LED is initially off. Then we'll add a rule to be evaluated every time the button is released. This rule will simply toggle whatever the current value of the logging flag is, as well as toggling the voltage on the GPIO pin connected to the LED. We'll add a second rule to be evaluated every time a new ANT packet arrives. In this rule, we check the logging flag state as our conditional, and if we're currently logging, we'll execute the action object to log the latest Tempe packet. Similarly, we do the same thing for packets from the sensor tag. Lastly, we add an event for application shutdown with a single rule that simply ensures that if the LED is illuminated, we turn it off before we exit. And again, we'll copy over our configuration file and restart the SoftHub daemon. Before we restart the daemon though, we'll look at the SoftHub's log directory, and as you can see, the only file there currently is the SoftHub system log file. Here again we have our ANT and Bluetooth low energy sensors connected to the SoftHub application running on the Raspberry Pi. The Raspberry Pi is again connected to our router via Wi-Fi connection and is forwarding the sensor packets to our AWS packet capture server via that connection. The laptop again has a remote desktop session to the AWS server so we can see the packets as they arrive. Lastly, in this example, we've attached a breadboard to the Raspberry Pi with a button and an LED connected to the two GPIO pins we configured in our rule file. So we'll start the daemon and hop over to our AWS server where we can see the packets arriving. Looking back in the log directory, we see that our log file has been created, but so far has a size of 0, indicating no data has been written. We'll press our button, and as we can see by the LED, we're now logging packet data. Looking at the log file size, we can see that it is growing. We'll press the button again, and logging halts, and the LED is extinguished. And now we can see that the log file is no longer growing. We press the button again and the log file again starts to receive packets. We'll press it one last time and again we stop logging data. That concludes our fourth demonstration video. Watch our final video where we introduce counters, averagers, cache, and custom user packets. And as always, thanks for watching.